In this video, I'd like to show you one of the ways a stylized shading can be done in your 3D game. I will also explain why you might choose to use stylized shading over realistic shading. If you're going for realistic shading, you can just go for half measures, as your player will understand that your goal was to achieve realistic look and any shortcomings will stand out. As a result, realistic shading requires a lot of not only computing resources, but also development resources. In most cases, you will need high-res textures, normal maps, but often also displacement maps, roughness maps, and that's just the tip of the iceberg, as water and reflections will provide additional technical and resource challenges. That's why most of the indie devs opt to either use pixel art or, in case of 3D games, stylized shading. You might find that AAA studios also choose stylized shading for games designed for lower-end devices, or even purely for the aesthetic reasons. Most commonly, a variant of toon shading is being used, which I have already covered on this channel, but many people complain that it does not work great with detailed textures or geometry. In this walkthrough, I'll create a shader that shades an object using lighting information and a screen space aligned brush. First, I'll set up the properties. These are the standard position, normal, and color. Note that you can use a UV and texture for determining the base color of the pixel instead of color. All of those will be passed as attributes of the rendered models. Second, I'll set up the brush as a global uniform, which will be shared between all models rendered using this shader. For that, I will need two properties, the texture region itself, as well as the scale of the texture. Let's start with assigning the position of the vertices using the position property. Next, I'll set up the lighting information. To do that, I need to connect the fragment world position to the position input of my chosen lighting node, plus a normal property that needs to be transformed to the world space coordinates. Finally, I'll use the color of the object. This produces a lighted output. Now let's use the shading texture property and calculate the UV based on the size of the texture. To do that, I need to multiply the size of the texture by the texture scale property and finally by the provided pixel size, which is reciprocal of width and height of the screen. Then, dividing the screen position by the calculated value, I get the UV of the texture in screen coordinates, and using a sample 2D node, I can extract the color information. This results in rendering of the tiled texture that was provided. Finally, we'll use the lighting information together with the tiled texture to finalize the shader. Instead of using the color property of the model, I'll use a fixed white color and calculate the intensity or luminosity of the lighted pixel. This will give me access to just the lighting information regardless of color of the model. Then I'll use the value from the shading brush to provide a cutoff for putting certain parts of the model in shadow. I'll use the output to decide whether I use a shadow color to be rendered, in this case a fixed black color, or the color of the model. You can experiment with different brushes and brush scales to achieve a unique look in your game. This library is available for download and use at my GitHub page. The link is also available in the description of this video. If you find this information useful, please consider subscribing to this YouTube channel, or you can watch some of the other videos on this channel.